Hello everyone. So today's topic is method of repetition. Right. Before starting today's topic, I would like to just revise what we have learned in the earlier classes. So we're actually dealing with the theodolite surveying. As you know, theodolite is the most precise instruments when compared to prismatic compass for measuring horizontal angle. Its least count is about 20 seconds, whereas compass is only about 30 minutes. And you can see this is a picture, and here you can see various components. We have in earlier classes we have discussed about each component and its function, where we are going to use all these. Okay. And also we have discussed about various technical terms or definitions we come across in theodolite surveying, such as fundamental lines of theodolite. We have vertical axis, something like this, and horizontal axis or Roman axis. Then we have plate, I mean axis of level tube, and line of collimation and axis of telescope. And also we have discussed about relation between them, and the other technical terms, such as what do you mean by face left and face right, swinging, swinging right and swinging left, and we have also discussed about how to measure a reading, how to take a reading from vernier A and B as well as C and D. Anyhow, that we are going to repeat once again because that is most useful in our class. Yeah. Coming to measurement of horizontal angles. So by using theodolite, you can measure horizontal angle in the three methods as listed here. General procedure, which we have already discussed, and now we are going to discuss in detail about method of repetition, and we have also reiteration method. And in general procedure, we have discussed that if you want to measure one reading, let us say if you want to find the reading, I'll draw over here. If I want to calculate the angle between survey lines OA and OB, let us say OA and OB using general procedure. What would be general procedure? Like we have to we have to site ranging rod at A station A with the zero reading of vernier A coinciding with the main scale 0, and then we have to release the upper clamp and turn the telescope towards B and then observe the reading once. This is to be completed with face left, and the same is repeated with the face right, and then we get the average angle, that is called the horizontal angle between the two lines. This is about general procedure. Now what is different in repetition, method of repetition in general procedure, we are going to see. So method of repetition, when we go for this method of repetition, adaptability. So here we go for method of repetition when we require higher precision in measuring horizontal angle. Let us say we want to measure a horizontal angle uh, below its least count. Let us say our instrument is having 20 seconds, and some other instruments may have 10 seconds least count also. Let us say right now our instrument is having 20 seconds least count. So in order to find angle which is below 20 seconds, let us say about 10 seconds or so, then we can go for this method, that is adaptability. Okay, and procedure, anyhow we are going to see in detail, and recording the same readings into tabular form. In the next slide I will be showing you a tabular form wherein we need to record all the readings in a sequential order, and then finally we are going to discuss about advantages also. Right. Again the same diagram. PQ is a line, a survey line. and QR is another survey line where we need to calculate angle between this I mean, uh, PQR angle. We need to find out the angle PQR using method of repetition, or I can also draw this is A, this is O, and B. And we require to find out the angle between these two survey lines OA and OB. So what is the procedure? So here theoretically in this method the angle is added number of times and the total angle is divided by the number of readings to get the accurate horizontal angle. So that is the main principle, and the angle is measured with the clockwise with face left observation once, and uh, a number of repetitions here. Minimum 3, we can take 4 or more also. If we require more accuracy, then we'll go for more repetition. But generally, in practical also, we'll go for the 3 repetition. That means we are going to take a horizontal reading with left and right swing, that is clockwise swing, and we are going to repeat the same angle measurement 3 times, and then we change the another face, that is face right, then again we move clockwise or swing with the swing right, again we are going to take for 3 turns, that is 3 repetitions. Okay, so here final reading of first observation will be the initial reading of the second observation and so on. And in this method, error due to eccentricity of verniers and inaccurate graduations and inaccurate bisections are eliminated. So these are all advantages. And so let us say angle AOB is to be measured by a repetition method. Then theodolite is set up at O and complete your all temporary adjustments, that is centering, leveling, and focusing all. Then vernier A0 reading should be should be exactly match with the zero of main scale. So in order to do so, what we have to do, we have to release both upper clamp as well as lower clamp, then turn in opposite direction till vernier A0 is exactly matches with the zero of main scale. Let us say it is approximately matching, then I can use a tangent screw or slow motion screw, that to upper tangent screw or upper slow motion screw to exact bisection of zero of vernier A with the zero of main scale. So once it is completed, then our telescope may be point to the any other direction which is not in line with the either of the survey lines OA or OB. Then what we have to do, the telescope direction we have to bring onto the line OA. So for this I can release a lower clamp. So why lower clamp? Means when you release lower clamp and tighten upper clamp, both plates together move and therefore there will not be a relative change. That means reading will not changes. But when you release upper clamp alone, that means lower clamp is tightened and upper clamp is loosened, then there will be only movement of the pointer or vernier A0 mark. Okay, the movement of verniers only on the uh, main scale. So there will be a relative change when you release lower clamp alone. These 2 points are to be remembered and do not confuse with them. When you release the lower clamp alone, reading will not change. and when you release upper clamp alone, there will be a change in the reading. So here in the initial stage, our telescope is directed to some other direction, and with this position we got exactly vernier A0 matches with the main scale 0. So we want to not to disturb the angle, but rotate the telescope such that it will be exactly in line with the OA. So for this we can release a lower clamp. Am I clear? I think am I clear up to here? So now I'm clear up to here. So uh, now I need to clamp both the clamps, lower clamp as well as upper clamp. Of course, for exact bisection of ranging rod at A, we may use lower tangent screw only, because when you operate lower tangent screw, reading will not changes. And here, another point to be noted: whenever you want to operate a tangent screw, the corresponding clamp screw must be tightened. When a clamp screw is tightened, then only a tangent screw works. Okay, so if the clamp is loose and clamps tangent screw does not work, now I need to measure the angle between A and B. Okay, with 0 on my survey line OA, now I should operate upper clamp screw. Upper clamp screw. When I release upper clamp screw and turn the telescope to bisect ranging rod at B, that is now telescope is in line with the OB. Okay. First instance, what happens? You can approximately bisect the ranging rod with the clamp alone. When you operate clamp alone, exact bisection may not be happen. If it is happens also, it will take a lot more time. So for minimizing our time constraint, we can approximately bisect by using upper clamp. Then you can tighten the upper clamp. For exact bisection, we have to use the upper tangent screw only, because when you operate upper clamp screw, reading still changes, and we can exactly bisect the ranging rod. Once ranging rod on B is exactly bisected, we have completed first repetition. So here I need to note down what is the reading on my vernier A as well as vernier B. Right. So in vernier A, I think we are familiarized by this time. We are familiarized with the readings, how to measure the reading on vernier A as well as vernier B. I just remind once again. In vernier A, we have to take the main scale reading in terms of degrees and minutes, and coming to vernier scale reading, we can search for the coincidence which of the line is exactly in coincidence with the main scale. Then we have to search for that particular line for coincidence, and then that coincidence line can be represented as vernier scale reading in the form of minutes and seconds only. Then the total reading at vernier A is simply summation of these two. So, so many degrees, so many minutes, and so many seconds you will get as vernier B. Sorry, vernier A. And when you comes to vernier B, what happens? Vernier B reading is actually 180 degrees more than the what is the angle. So simply you need to subtract 180 degrees from the vernier, uh, I mean 0 of vernier B, or otherwise simply you can keep the same main scale reading as we got in the vernier A. That is more easy, I think. So when you come to vernier A, main scale reading will be same as vernier A. When you come to vernier B, main scale reading will be same as vernier A, and only thing you need to do is search for the vernier coincidence again in vernier B. So here coincidence may be a slightly different from the what you have got in vernier A. It may be slightly here and there, 20 seconds or 40 seconds here and there. So again, you have to sum up main scale reading as well as vernier scale reading of vernier B, and then when you add these two, you will get the final reading on vernier B also, right? Then the average of these two is nothing but one reading, repetition one reading on first set. Let us say we are doing completely this complete process, let us say with the face left. Now we got first reading of face left. Okay, we are going to see a tabular form also. Yeah, the tabular form speaks with respect to PQR, or you can also speak with respect to AOB. Right. When instrumentation is yeah, this table is correspond to repetition method, and instrumentation is at actually Q, and we are cited to initially P, cited to P, and with face left and right swing, and that means clockwise rotation. Uh, for the initial position, that is on QP line, we get everything 0. 0 degrees, 0 minutes and 0 seconds in vernier B, A, and in vernier B also 0 minutes and 0 seconds, and finally the average angle is also 0 degrees, 0 minutes and 0 seconds. So like this we will get. And similarly when you rotate, or when you complete first rotation, then what happens? 52 degrees is a main scale reading, 52 degrees 40 minutes is main scale reading, and 1 minute 20 seconds is vernier scale reading, and when you add these two you will get 52 degrees 41 minutes and 20 seconds. Similarly on vernier B we will write only minutes and seconds. We in tabular form there is no provision for writing degrees, only minutes and seconds we can write, and that too on vernier B when you search for coincidence you will only get 1 degree 20 minutes, but we need to add the minutes of main scale reading to here also. That means in the vernier A, if I got 52 degrees 40 minutes as main scale reading, that 40 will be added here also. So therefore 41 minutes 41 minutes and 20 seconds on vernier B. Then the average of these two will be 52 degrees 41 minutes and 20 seconds, and this is the first set reading, a repetition one horizontal reading. Now we'll go back to the diagram again. Now what we are going to do, we must bring a telescope onto OA line again, or I can say QP line again, but without any disturbance in the reading. So that means I should operate lower clamp screw. That means when release lower clamp screw and turn the telescope towards P and bisect P exactly again with the help of lower clamps. I mean, you can tighten the lower clamp and then operate lower tangent screw for exact bisection. So here, why lower clamp screw and lower tangent screw? Because we don't want to change the reading. We want to keep reading as it is for the first set. And we know when you operate a lower clamp and lower tangent screw, reading will not changes. Now for the second time, QP QP line is exactly, telescope is in line with the QP line. Now I need to measure for the second time again the horizontal angle with face left only. Now I must release upper clamp here, upper clamp, because I want to change the, I want change in the reading, or I want to record the reading for the second time. Therefore release upper clamp and turn the telescope towards R, and with approximate bisection at R you can fix the upper clamp screw. And for exact bisection again you can use the upper tangent screw. Let us say with the upper tangent screw and upper clamp screw I have exactly bisected ranging rod at R with the instrument at Q for the second time. Let us say this is first and this is second time. Now the instrument is ready for taking readings on again vernier A as well as vernier B. So for the second time again at vernier A you should take main scale reading and vernier scale reading, then add these two readings, and you can list write down in the tabular form. If it is 52 degrees for the first time, it may be some 104 degrees, around 104 degrees for the second repetition. In the tabular form it is directly written like first repetition and directly third repetition, but in between there must be a second repetition also. So therefore it may be around 105 or 104 degrees, 105 some change. Okay, right, we'll go back. With vernier A, I have taken main scale reading and vernier scale reading. It may be something like this. And in vernier B also, I need to consider for only, I need to search for the coincidence only, vernier coincidence only. And for that coincidence, I need to add main scale minutes we have got in the vernier A. Okay, just like we have got 40 minutes and here only 1 minute and 20 seconds, but still I need to add 40 here. Similarly, a similar kind of thing applied here also. So again, average of these two will be giving, will be give you a horizontal angle, a total horizontal angle for second repetition. Okay, we'll go back again. And with this, we have completed our second repetition with face left. Okay. Now I have to again bring back this telescope onto a line QP or PQ. So for this operation, I should release the lower clamp and rotate the telescope back such that telescope is now exactly bisected to P. You can say roughly bisected to P, and then you can operate lower tangent screw by fixing lower clamp screw, operate lower tangent screw for exact bisection of P. So while doing so, you should be careful that reading will not change, I mean does not change uh, okay, from the previous one. Now again for the third time we must measure the reading or angle between this QP and QR lines for the third time. So for this again I must release upper clamp screw and rotate the telescope to bisect ranging rod and R approximately. With this approximate bisection, clamp upper clamp screw or fix upper clamp screw. Then by operating upper tangent screw only, I need to bisect exactly the ranging rod on R. Now instrument is ready for taking noting down the third time reading. Now I will go back to the diagram. So here on the main scale at vernier A, I'll get for this particular case I got 158 degrees and 00 minutes as main scale reading and 4 minutes and 40 seconds as vernier scale reading. And when you add these two, finally 158 degrees, 4 minutes and 40 seconds is my angle for the third repetition at vernier A. Similarly, at vernier B, only coincidence has to be taken, that is 4 minutes and 40 seconds, but minutes of main scale reading at vernier A should be added. So minutes of vernier scale, for instance, is 0, that means nothing to be added here. And finally, average of these two is 158 degrees, 4 minutes and 40 seconds. This is my third time angle. Now, difference of first two readings is my horizontal angle for the first time, and difference of second and one is the horizontal angle for the second time, and difference of third and two is a horizontal angle for three times. Likewise, I'll get three horizontal angles. So here you can observe a horizontal angle column, minutes, degrees, minutes and seconds. So I need to get three different readings. Then average of these three readings is a final reading on with face left. Okay. So we have completed half of the procedure by now. That means these three average is will give you a final reading in face left. Now we have to repeat the entire process with the face right also. Face right also. Okay. Uh, we'll go back to the diagram again. So what we are going to do, uh, we can transit the telescope and rotate. By transiting, you're actually changing its face from left to right. Then rotate, release both clamps and rotate opposite direction both the clamps, so that vernier A should exactly, 0 of vernier A should exactly matches with the 0 of main scale. Once it is done, the telescope may be pointed in any other direction but not on exactly PQ or QR always. So here let us say telescope is in this direction when 0 of vernier scale is exactly matches with the 0 of main scale. Now release the lower clamp and turn the telescope, okay, uh, from here to onto the line QP exactly. I'll just erase these two. Okay, now the telescope is exactly in the direction of a QP, and for exact bisection you may use lower clamp and lower tangent only. So with the lower tangent you have exactly bisected QP line, and now reading on main scale is 0 0, and face of the instrument is with face right. Okay, now again you can repeat the process actually. So again you are going to release the upper clamp here and rotate the telescope to bisect to approximately ranging rod R, and then for exact bisection, for exact bisection you may use upper tangent screw, and once bisection is completed for the first set, I'll erase those two sets. Okay, once first set is completed and the instrument is ready for taking measurements, then you can record the same in the tabular form. Face right column. So here half of right half is for face right and the right swing. So here when the instrument is on P, again reading is 0 0 0. So entire 0 you will get, and then what we have to do, when you complete first repetition, you can observe the reading on vernier A as well as vernier B as previously. Main scale reading in addition to the vernier scale reading is a combined reading on A, column A, degrees, minutes and second. Similarly in column B, only minutes and seconds have to be recorded, and then average of these two will give you mean horizontal angle, that is 52 degrees, 41 minutes and 40 seconds. This is for first repetition, and then release a lower clamp and rotate the telescope onto line QP exactly, and then bisect this ranging rod at P exactly with the help of lower clamp and lower tangent screw only. Once you have bisected, now we need to measure the angle for the second time with face right. So here again I need to release the upper clamp and turn the telescope towards R and Q. Now approximately bisect R with the help of clamp screw, and fix the upper clamp, and with the help of upper tangent screw you can exactly bisect the ranging rod on R. Now with this we have completed second repetition, and instrument is ready for taking readings at the second setup. So here in the tabular form second repetition is not given, but we need to record here. It may be around 105 or 104 degrees for this particular angle. And once recorded in the tabular form, then we must release a lower clamp here and rotate back telescope onto line QP, and for exact bisection you may use you may fix the lower clamp and use lower tangent screw for exact bisection. Once it is exactly bisected, then it is ready for third set. So turn the telescope, release the upper clamp and turn the telescope towards R for approximate bisection of R. Then you can clamp upper clamp screw, and use upper tangent screw for exact bisection of R. So with this set, the instrument is ready for taking third reading, and you can take the, note down the reading and enter in the tabular form. Vernier A in terms of degrees, minutes, and seconds, and vernier B in terms of minutes and seconds, and average of these two is nothing but the mean horizontal angle. And as usual, the difference of, yeah, the difference of first and zero set is nothing but horizontal angle 1, and difference of second set and first set is horizontal angle 2, and difference of third and second set is horizontal angle 3. Like this, we'll get 3 horizontal angles, and out of these 3, when average of these 3 will be 1 horizontal angle with face right also. Then average of these two, face left as well as face right readings, will be the final horizontal angle. And you can see here 52 degrees, 41 minutes, and 33 seconds. No, I think it is written wrongly. It is 30 seconds, not 33, 30. So 30 seconds, that means 10 seconds, up to 10-second accuracy we got, whereas actual instrument is accuracy up to 20 seconds only, but with the help of this face left, sorry, the repetition method, we got around 30 seconds, sorry, 10 seconds least count also. Okay, so I think with this we can conclude a session for today. Okay, just we want just we revise our class. So today we have revised a previous topic, and we have also actually completed general procedure of measuring horizontal angle with the help of that. And after completion of general procedure, today we have discussed about repetition method in detail, and what is a adaptability, or there is situation where we go for a repetition method, and in detail what is a procedure, how to record in tabular form, how to calculate the average of face left and face right, everything we have completed. And now we'll see what are the advantages. Right. So number one is errors of graduation can be eliminated by changing initial reading and the reading the angle on different parts of graduated circle. So there may be a possible that while manufacturing in the manufacturing itself, the graduated circle, that is a main scale, may be printed wrongly. That means first quarter may be a little closer, and to balance that second quarter may be a little distant away. So that may happen. All the 360 degrees may not be equal. Some may be closer, or some may be far away. So for that for that particular case, by adopting a repetition method, you are forced to use different parts of circle. Let us say you are going to repeat 3 times, and the angle is 50. 50 for the first time, 100 for the second time, and 150. So almost half of the circle is covered, something like that. So you are forcibly going to use different parts of the circle, and then you are averaging. That means error present anywhere in the circle, that may be minimized. Number one. And number two, personal errors of bisection can be minimized by large number of observations. So here, personal errors, let us say while bisecting, you have not bisected exactly, a little here and there maybe happen often. So if it is done only for first time, a single time, then the error is unnoticed. Whereas you are repeating the entire process, maybe you can say 6 times, with face left 3 times and face right 3 times, total 6 times. So by doing 6 times and averaging, definitely there will be less error when compared to a single time calculation. Now error due to eccentricity of centers, that the verniers are eliminated by reading both verniers. So if two verniers are eccentrically placed, then the eccentricity is eliminated in repetition method. And error due to the line of collimation not being perpendicular to the transverse axis of telescope and eliminated, that is also eliminated by taking both face left and face right readings. Then errors of manipulation are minimized by changing swing, using right swing for the half observation and the left swing for the other half. So like this, a number of advantages are there using repetition method. Okay, so I think we have clearly understood the process, and anyhow we are going to do practically with the instrument at our college practicals. Then I think you will be getting a clear picture, because you are going to actually practice the entire process and record the readings. Then definitely you will be getting a lot of doubts, and you will be clarified on the field itself. That is the advantage of this subject. We are going to learn the practical work or theoretical work at the class, and we are going to do the same with the instrument, actual instrument over here. Anyhow, these theodolites and all, nowadays we are not using manual, because everything is latest instruments are used electronic theodolite and total station, wherein with a just a click, one click, we are going to get the horizontal reading as well as distances and angles, gradations, whatnot. uh, but the basic is here only. We have to learn the basic with the manual theodolites only. Then we can use the higher precise instruments also. Okay, so this is a tabular form, and this is actually the next method, reiteration method, and I'll going to discuss in detail about that method in the next class. Yeah. Thank you for now. I hope this lesson is useful to you, and we'll meet in the next class with the other topic.